Hello dear students, welcome to Europedia. Today I am going to discuss one of the famous questions that was asked previously in DRDO interviews for electrical engineering candidates. The question looks very simple, but how the interviewer will extend that question we are going to see. And the question is very particular. Okay, if it looks like, see, if you look at the question, it looks like very simple. What is a balanced system? If I ask you what does it mean by balanced system of currents or voltages or load, you will answer with some 10 plus or minus 10% wrong. Okay, 90% people will give correct answer, or 90% of the answer you are going to give, but 10% you are going to miss, which is very important. Let's see what does it mean by a balanced system. Let me take first of all, what does it mean by balanced system of currents first? Balanced system of currents, or let's take balanced system of voltages. See, I have three phase voltages. See, this balanced or unbalanced will come only for three phase system, okay, not for a single phase system. Yes, now I have phase A, VA of t, I am writing it as Vm sine of omega t. VB of t is equal to Vm sine of omega t minus 120. Vc of t is equal to Vm sine of omega t minus 240. Yeah, many things we are going to discuss here. Okay, for a system of voltages to be balanced, the maximum magnitudes of all three phase voltages must be equal. If the maximum magnitudes are equal, I can say simply this one I call it as Vma, this one as Vmb, this one as Vmc. Then what is the first condition that is required is, see, for system of voltages to be balanced, yes, the very first condition required is, yes, yeah, Vma is equal to Vmb is equal to Vmc. All three phase maximum magnitudes of the voltages must be equal. If the maximum magnitudes are equal, obviously RMS values, average values are going to be equal. Yes. What is the relationship between maximum voltage and RMS voltage? V RMS is equal to Vm by root 2. Yes, that's all. That is the first condition. It's not enough. The second condition is the phase angle between the consecutive phases. Okay, you have to use the word consecutive. The phase angle between the consecutive phases must be equal to 120 degrees. See, now here it is looking like 120. See, it is looking like, means it is visible. 120 is visible to you. There is no confusion. Suppose if I take some 30 degrees here, then yes, omega t plus 30 means this particular phasor is starting at a minus 30 degrees, right? Now this should be minus 90. Yes. Now you see, do not try to subtract the values. You draw the phasor. That is good. That is a good thing. To avoid confusion, draw the phasor. So take 0 degrees as a reference. Okay, I am taking this one as 0 degrees with a dotted line. This one as 0 degrees. Okay, this is 0 degrees. Now this is omega t plus 30, means it is starting at omega t equal to minus 30, right? Omega t equal to minus 30. So here it is Va, I can call. So this particular one is 30 degrees. Yes. Yes. And I want Vb to be 90 degrees after Va. I want Vb to become either maximum or minimum after 90 degrees as that of A. That is called as phase sequence. What is phase sequence? Va, Vb, Vc we have. Va will become maximum at omega t equal to 90, then Vb has to become maximum after 120 degrees of Va. After 120 degrees of Va maximum, in fact. Yes. So now how much angle I have to take for Vb from 0 degrees in such a way that the angle difference between Va and Vb is 120, 90 degrees means, see, this is Vb. This is Vb. So this total is 120 ma. This total is 120, and this particular value from 0 degrees, this is 90 degrees only. 90 plus 130, 90 plus 30 will be 120 only. Yes. Now we have to calculate for VC. Now tell me what should be the value of VC. So from here to here the difference should be 120, means for 90, 120, how much it is, 210. Yes. So this is 180, this particular one is 180. Yes, this is 180. Yeah, 0, and exactly opposite is 180. Yes. And this is VC, this is VC. So 180 plus how much angle will become 210, 30 degrees. This is 30 degrees. Yes. And this particular value is 120. Now if you look at the angle between VC and VA also, if total is 360, this is 120, this is 120, this is also 120. Yes, this is the second condition for this system of voltages to be balanced. Okay, they will give you some equations like this. They will ask you whether those are balanced or not. You'll get literally confused. Sometimes what they give is, one they will give sine, one they will give cos. Convert cos into sine, but be cautious there while converting. Okay, convert sine into cos, or one cos is given, convert that cos into sine. Okay, and what is the second condition? Let me write the second condition here. See, the phase angle difference between consecutive phases. See, if you are going in clockwise, this is clockwise, right? Between VA, VB, VB, VC, VC, VA. A to B angle is 120, B to C angle is 120, C to A angle is also 120. If you are coming like this, A to C 120, C to B 120, B to A also 120. The phase angle difference between the consecutive phases must be 120 degrees. Yes. The phase angle difference between the consecutive phases between the consecutive phases must be 120 degrees. If these two conditions are satisfied, then that system of voltages is said to be balanced. That is a balanced system of voltages. Now, what is the outcome of a balanced system of voltages? If these two conditions are satisfied, then VA plus VB plus VC is equal to 0 at any instant. See, many people will rely on this outcome. This is not the condition. This is the outcome what we are going to get once these two conditions are satisfied. If this one and this one both are satisfied, then this is the outcome. But converse is not true. Means, sir, if this satisfies, then it is going to be balanced or no. Suppose if my current is 0, 0, 0, all three 0, or minus 1, 0, 1, 0. So it's not that if this condition satisfies, system of voltage is said to be balanced. No. Maximum magnitudes must be equal and consecutive phase angle difference must be 120. If those two satisfies, then automatically this will satisfy. Okay, this is the outcome. This is the result, but not the condition. Okay, so this is the condition for voltages. Now, what is the condition for currents? Currents are not in our hands. Currents are there in the hands of source and load. Let's take some connection between sources and loads. Okay, I'm going to take some connection. Yes, from there I'm going to explain what does it mean by a balanced system. I have a three-phase system like this. I have a three-phase system. I'm taking star connected network, star connected source. In fact, star connected source I'm taking. Okay, yeah. Now, this is the wire that is connecting between that is getting connected between source and load, and here I'm taking star connected load also I'm taking star connected. Okay, be careful while connecting. Okay, phase A is given to A of load, phase B is given to B of load. So like that we have to maintain that sequence. Okay, yes. Now this is a plus minus plus minus plus. So this is a VA, this is a VB, and this is a VC. This is RA, this is RB, this is a RC. This is the neutral point of the load. This is a neutral point of the source. Now what I do is I'll connect these two. These two neutrals I am connecting with a wire. All connecting wires impedances are taken as 0. Means I am using a wire from the source to the load to connect between these 2 points. I am assuming that impedance is 0. If not, that impedance also we have to consider. Yes, for a transmission line power systems, this is the transmission line. In fact, this is generator and this is load. This is the transmission line. The transmission line impedance ZL of phase A, Z small l, line impedance we are taking Z small l. This load impedance we will take it as a Z capital LA. Okay, but here for simplicity I taken resistive loads. Now tell me, how much is the current that is flowing in phase A? How much is the current that is flowing in phase A? IA, that is equal to VA by RA. How much is the current that is flowing in phase B? IB, that is equal to VB by RB. In this, IC is equal to VC by RC. Now when, see, let's write those formulae. Let's write those formulae here. Okay, so IA is equal to VA is what? Vm sin omega t plus theta by RA, or plus 30. Instead of 30 I am taking some theta. Okay, then what is IB? That is Vm by RB into sine of omega t plus theta minus 120. IC is equal to Vm by RC, Vm by RC sine of omega t plus theta minus of 240 degrees. Angles match, no issues, angles match. So the difference between this and this and this and this, you can take it as 120 degrees only. But all thetas must be same. If this is 30, this should be 30, this should be 30. And we know that all these Vms are equal. I taken balanced system of voltages. Now if RA is equal to RB equal to RC, then only, yes, those currents are said to be balanced. Now if RA is equal to, or instead of R, let me take it as Z, something I have to discuss here. Yes, let me take it as Z, that is better, ZA. Though symbol I am representing it as a R resistance symbol, but it is ZA. This is some connection is missing here. Yeah, so this is ZA, this is ZB, this is ZC. So let me take this one as ZA, ZB and ZC. Yes, ZA, ZB and ZC. Observe here, this Z is also going to have magnitude and angle. Why? Because it's impedance but not only the resistance. So I need this ZA, ZB, ZC to be equal. If ZA is equal to ZB is equal to ZC, then see, I can call this one as IAM, means maximum magnitude of phase, maximum magnitude of the phase current of A. Okay, let me write in another page, let me write in another page, we'll get more clarity there. Yes, so IA is equal to IAM or IMA we take. Okay, it is looking like IAM. Okay, IM of A sine of omega t plus theta. IB is equal to IM of B sine of omega t plus theta minus 120 degrees. IC is equal to IMC sine of omega t plus theta minus of 240 degrees. If you observe, I need IMA to be equal to IMB to be equal to IMC is the first condition required, and anyhow angle is 120 degrees. It is looking to us, it is visible to us. So this is possible if ZA is equal to ZB is equal to ZC. Whether currents are balanced or not will be decided by voltages, line impedances and load impedances. All three line impedances must be equal in terms of magnitude and angle. Okay, all three load impedances must be equal in terms of magnitude and angle. Then only that system is said to be balanced. See, if we talk from this side, all three voltages must be balanced. Means what? All three voltages maximum magnitudes or RMS magnitudes or average magnitudes must be equal. If all three RMS values are equal, means obviously maximum values are equal. And all three phases must have a phase angle difference of 120 degrees between the consecutive phases. Yes. Now these are the connecting lines between A to A load A phase, see source A to load A, source B to load B, source C to load C. Those lines, suppose if it is having ZLA, ZLB and ZLC, here we are going to get S plus ZLA, yes, plus ZLB plus ZLC, right? Yes or not? Now the condition is, and I have to write ZLA is equal to ZLB is equal to ZLC. Yes, then only it is possible. Yes, IMA is equal to IMB is equal to IMC if ZLA and ZLA is equal to ZLB is equal to ZLC. Not only magnitudes but also angles. See, if you look at here, why I am concentrating on that point, not only angles but not only magnitudes but also angles. Let me tell you here. Suppose if you take ZL or ZA only, we will take ZA is equal to 1 plus J1, ZB is equal to 1 minus J1. Now if you see, what is the magnitude of ZA? Mod ZA is equal to root 2 What is the magnitude of ZB? Mod ZB is also root 2. But if you look at the angle, I'll call it as a theta A, that is equal to 45 degrees. If I take a theta B, that is equal to, yes, minus 45 degrees we are going to get. Now if I take ZC is equal to 1 plus Z1, this is not a balanced system. Though magnitudes are equal, angles are getting differed. For load, all angles also must be equal. I'll write that point also. I'll write that point also in the form of note. Yes. Note, very important point this is. Loads are said to be balanced. Loads are said to be balanced if mod ZA at an angle, mod ZA is equal to mod ZB is equal to mod ZC, and angle of, let me write like this, angle of ZA is equal to angle of ZB is equal to angle of ZC. Yes. Now this is a complete balanced system. Okay, so this is called as balanced system. Currents must be, voltage must be balanced, loads must be balanced, and connecting lines should be balanced. Then only currents will be balanced. So currents, whether balanced or not, is going to depend upon total entire system condition. Thank you.